Google has introduced their Gemini AI. This Gemini AI is built from the ground for multimodality, and as per their blog, it kind of beats GPT-4 on many tasks. They've also released a technical report explaining, what is the model and explaining the data and other things. So I thought I'll have a look at the technical report, and I just had a quick read. But then Chip Huon and Alexa Kodak have actually summarized it nicely on LinkedIn. So I thought I'll refer to this post directly for a summary. Okay. So Gemini was written in JAX and trained using TPUs. The architecture, while not explained in details in the technical report, seems similar to DeepMind's Flamingo with separate text encoder and vision encoder. This is what Chip has here. And Alexa says that Gemini is natively multimodal, trained from scratch on different modalities. Compare that with Flamingo. Step 1 is train an LLM, train a vision encoder using contrastive pre-training. Step 3 freezes the backbone and trains the system end to end. So the input could be text, audio, image, or video, and the output is text or image. Okay. So this is about, at a high level, what is the architecture. Details are not present. And Gemini Pro's performance is similar to GPT 3.5, and Gemini Ultra is reported to be better than GPT 4. Nano 1 and Nano 2 are having very less parameters, 1.8 billion parameter and 3.25 billion parameters. These are designed to run on device. So Nano is going to be available on Pixel 8, right? And the model has 32 context length. Is very good at understanding vision and speech. In coding ability, there is a big jump in human eval compared to GPT-4. If true is awesome, that's what Chip says over here. However, the natural to code benchmark, which has no leakage on the internet, shows a much smaller gap, okay, between GPT-4 and Gemini Ultra. Okay, on this MMLU benchmark, they're using chain of thought at 32 samples to show that Gemini is better than GPT-4, but she says seems forced. Okay, in 5-shot setting, GPT-4 is better. And not all information. No, there is no information on the training data. They say that they ensured all data enrichment workers are paid at least a local living wage. So there is no details on the training data as such. Okay, but if you look at the paper, what they say over here is that it has been trained on your multiple data from the web. That's what they have said over here in this particular. They talk about the training infrastructure, about the training data set. It is both multimodal and multilingual. The pre-training dataset uses data from web, documents, books, code, and includes image, audio, and video data. That is what they are saying over here. And with respect to the model itself, what they are saying over here is that Gemini supports interleaved sequence of text, image, audio, and video as inputs, and it can output responses with interleaved image and text. Okay, that's what was told over here also in the summary. And these are the 3 model sizes. And Nano 1 and Nano 2 are actually trained by distilling from larger Gemini models. It is 4-bit quantized for deployment and provides best-in-class performance. The Pro is a performance-optimized model in terms of cost as well as latency that delivers significant performance across a wide range of tasks, and Ultra is their most capable model. Okay. An interesting thing which Alexa says over here is that the Ultra is actually trained, they combined superpods in multiple data centers using Google's intra-cluster and inter-cluster network. So there is parallelism across GPUs, there is parallelism across data centers. So that is what, how they have trained it. Okay, the rest is about performance over here in this summary. I'll be putting both these LinkedIn posts in the description of the video. You can check it out. Then if you go over here into the report itself, what I was interested was, what is capable, some examples, okay, of what is capable with this model, right? So that is interesting over here. These could be select examples, but still you kind of get an idea on what is possible, right, with this kind of models. So here is the first example of chart understanding and reasoning over data. So given a chart like this, right, which is share of plastic waste that is recycled, landfilled, and incinerated and mismanaged, you can ask a prompt like, given this chart image, a prompt like this: spot a data point that stands out in these charts and what that implicates, and then produce a detailed markdown table for all the data shown. So basically, the model has to understand this image and then find out. So the model gives this response says that the data point that stands out is the United States landfilled plastic waste, which is 73%. This is the data point which is standing out. This means that US is not doing enough for recycling or incinerating its plastic waste as other countries and regions. So that is the insight it has pulled out from this particular chart. Okay. So this is a problem. Solving this problem requires multimodal chart understanding. The model has to read text, understand the connections between different data points, reason over them to recommend an interesting point. Okay. This is another example. There is a picture of this plant. So the prompt is, do you know this plant? How do I best take care of it? So it identifies this as a Persian shield plant and it says what needs to be done. Again, multimodal information seeking query. So the model is able to recognize the specific plant and then provide information. Okay. Then there is interleaved image and text generation. So basically here the prompt is to create a blog post about a trip to New York where a dog and his owner had lots of fun. Include a few pictures of the dog posing happily at different landmarks. Okay. And here is the model response. It is able to generate text as well as interleave it with images. So this is quite interesting. Then you have image understanding and reasoning. So given this image, there are a sequence of shapes, right? A triangle, a square, and then you have a pentagon. So what is the next shape, right? So it says that the fourth shape should be a hexagon because the first is a triangle, second is a square, third is a pentagon. So sides, number of sides in each shape is increasing by 1. So it is able to solve this reasoning problem. Okay. Then it is also able to do geometrical reasoning. For example, given this, find the height of a parallelogram given its area. So it says the area of the parallelogram is equal to the product of the base and height, and it tries to solve this equation. Okay. You can also do information seeking about objects. So find a connection between two objects over here. So there is the moon and there is a golf ball. So the moon is the only celestial body in which humans have played golf. In 1971, the Apollo 14 crew hit 2 golf balls on the lunar surface. Okay, so solving puzzle using multimodal inputs. Multimodal reasoning based on visual cues. So given a picture, do you know the precise location? So it identifies this Empire State Building and it says this is taken in New York City. So identifying the objects in an image and recognizing what those are even with small levels of visual distortion in the image. So based on this image, it is able to do it in a precise manner. Okay, it can also do multimodal humor understanding. Okay, so there is this meme. Okay, a person who tries to play a game at 300 fps on a 75 hertz monitor. Okay, so it explains that this meme is about a person who is playing a game at 300 fps, but their monitor is only 75 hertz. The person is trying to catch the game, but is too fast for their monitor to display. Okay, so it explains that. It can also do common sense reasoning in a multilingual setting. So there is this basic Chinese family tree, right? And explain what should I call my grandparents. So, the kid is highlighted over here on each side of the family based on this chart. So it says on the father side, you would call your grandparents Yeye and Nene. So based on this, on the mother side, this basically it is able to understand this image, understand this tree structure, understand this hierarchy, and then pull out everything. So this is very interesting, common sense reasoning in images. It can do reasoning and code generation as well. So there is an create a web app called Opossum Search. There are a set of instruction and it is able to generate code, right? And it can render that website as well. It can do mathematics, calculus calculations. So find the derivative of sin hx cos hx is equal to x plus y. It does that. It's also a calculus problem. And then it can do multi-step reasoning and mathematics. Okay, so given a problem with multiple steps, it is able to do it. It can do complex image understanding, code generation, and instruction following. So there is this particular image. It says, I want you to take the function depicted in the top left subplot, multiply it by 1000, and then add it to the function depicted in the bottom left subplot, and generate matplotlib code for the single resulting plot. So it is able to do that. So Gemini Ultra needs to perform inverse graphics task to infer the code that would have generated the plots, perform additional mathematical transformations, and generate relevant code. It can do video understanding and reasoning. So here is a person playing football, right? So how could this person improve their technique? So basically frames from the video as given as input. So it says the soccer player needs to work on their ball striking mechanisms, and it gives an explanation over here. So it can do video understanding and reasoning. So here are some of these examples and use cases in the technical report. You can check it out. You can check out other details also. These could be selected examples, but you get an idea of what can be done with this particular model. So this is a short video on the technical report of Google Gemini AI. And I have used the summaries of Chip Huon and Alexa Gordic to explain more about this. I'll be putting the link to all these LinkedIn posts as well as this technical report in the description of the video. I hope this video is useful for you. If you like the video, please like, share, subscribe to the channel. See you in another video.